When an animated flock of birds discovers their eggs have been stolen by invading green pigs, the emotional reaction appears spontaneous. The audience watches an outcast bird rally his peers into a frenzy, and the scene feels like a living, breathing moment. That experience is an optical illusion. Strip away the final render, and the character dissolves into its underlying technical framework, a massive feat of digital engineering. Moving a story from initial animatic sketches to a final 4K theatrical output involves processing hundreds of terabytes of data. Every shadow, feather, and dust particle is a mathematical value plotted on a coordinate system. To understand how a studio creates a high-stakes emotional climax, we have to reverse engineer the sequence and uncover the production pipeline. This analysis focuses on the math of the production, specifically how motion capture, dynamic character rigging, and multi-track timeline editing are used to control the audience's perception of the story. The first technical hurdle is raw data management. Creating a dense 3D environment requires compressing a massive volume of visual information into a playable format without losing fidelity. This graph illustrates the scale of the challenge. The erratic spikes represent the massive data load of an uncompressed master file. To deliver this to a viewer, that data is algorithmically optimized into a streaming codec like H.265. Technical tools, not just the script, serve as the primary drivers of narrative pacing and audience retention in modern animation. The character pipeline begins in the recording studio. A voice actor's performance must be translated into the facial movements of a 3D model. Animators use phoneme-based animation to bridge this gap. Every distinct vocal sound, like an O or an F, is mapped to specific mathematical points on the digital character's face. To prevent static dialogue, animators apply the squash and stretch physics principle to the facial rig. The geometry distorts and snaps back, creating exaggerated expressions. Syncing the mouth is only one half of the process. Raw studio audio sounds sterile. It must be processed to sound like it exists within the physical space of the scene. First is audio cleanup. A jagged waveform passes through a filter, stripping ambient noise for uniform volume. Then, equalization carves out space on a multi-track grid. Lowering specific frequency bands ensures the voice isn't drowned out. Perfectly clean audio feels unnatural in a 3D world. To finalize the effect, engineers add artificial reverberation to match the visual environment's echoes. The combination of the visual squash and stretch rig and the manipulated audio track creates the illusion of life. Successful dialogue in animation is essentially a highly coordinated trick played on the audience's auditory and visual processing centers. During an action sequence, like a heist, animators must build a sense of scale and chaos. Each frame of the sequence is an assembly of dozens of independent visual layers stacked on top of each other. The foundation is global illumination, calculating how light rays bounce to establish environment lighting. Next, the midground layer adds motion-captured characters. Then, the foreground layer injects thousands of autonomous dust particles. Finally, simulated depth of field blurs this foreground, forcing focus onto the characters. These complex frames are then assembled on a non-linear editor timeline to generate momentum. Editors cross-cut between the antagonist's escape and the protagonist's reaction. This mathematical sequencing of shots is designed to increase tension. To keep the momentum high, motion blur wipes mask the jump cuts, creating a seamless sense of speed. Action is the precise management of compositing depth and editorial frame rates to induce anxiety in the viewer. In an emotional climax, like a motivational speech, the audience's mood is manipulated through subtle technical adjustments. This manipulation starts in the color grading pipeline, beginning with a base conversion to the Rec. 709 color space. Colorists use a node-based interface to separate the image into targeted regions. Each node allows for a specific adjustment to be made before the data reaches the final monitor. After primary white balance corrections, the colorist performs secondary grading. They deliberately push the shadows into darker, cooler tones to evoke a sense of anger or seriousness. This dark environment is contrasted with targeted highlight isolation on the protagonist's face to draw the audience's absolute focus. The unseen driver of this emotion is the 5.1 Dolby Atmos sound design. This radar grid illustrates spatial audio. Foley sounds are assigned 3D coordinates, orbiting the listener in a 360-degree space. During a speech, adaptive mixing slowly fades out environmental Foley, isolating the vocal track to make it intimate and powerful. A hybrid orchestral and electronic score is introduced underneath the speech to build a subconscious crescendo. Cinematic emotion is achieved when secondary color contrast synchronizes with the isolation of spatial audio. The final stage is preparing the master file for multiple platforms without compromising the engineering. This requires audio normalization to lock the project to industry loudness standards. This line represents -14 LUFS. If the audio exceeds this threshold, streaming platforms will automatically crush the waveform, flattening the dynamic range of the climax. The same problem exists visually when reframing a theatrical widescreen movie for mobile social media. The focal point of the scene is mathematically split across 3 different aspect ratios simultaneously. A targeting reticle ensures the subject remains centered, whether the viewer is on a cinema screen or a phone. This cross-platform optimization ensures the viewer's psychological experience remains intact, regardless of their device. This is the complete journey from the raw voiceover transcript to the final optimized 4K render. Dynamic rigging, Z-depth compositing, and spatial audio are the actual building blocks of the narrative. Ultimately, high-end animation is the precise technical integration of physics, editing, and spatial data to deliberately manufacture human emotion.